Hello everyone, my name is Elaine Chong, and today I'm going to demonstrate on how to implement gradient descent for simple linear regression. Gradient descent chooses the parameter of a model in a way that minimize some measure error in the model. There are one approach to maximize or minimize a function. First, pick a random point. Second, compute the gradient. Third, take a small step in the same or opposite as the gradient. Fourth, repeat with the same starting point. We can see in the find minimum function, first, we generate a random point v in the range from minus 10 to 10. The n means the number of variable we need to generate. Like if the n is 2, then we will generate something like this. But if the n is 3, we will generate one more parameter. Second, we need to estimate the gradient here. The formula to find a gradient is y2 minus y1 divided by x2 minus x1. As a result, we will get a formula like this. When we call this function estimate gradient, we pass the function, the current point, and the h. It will return the partial differential quotient. Let's see. In this line, we add h to just the I element. For example, we only add h when the element is x and we pass the x, or we only add h when the element is y. Third, we need to find the new point. We call the new step function, pass in the current position, the gradient, we show the direction, and also the step size we want. We set the step size as 0.01 and we call the function, we will get the next v. The loop will go on until our current point and the next point is less than tolerance. We calculate the distance using Euclidean algorithm. It is we square the sum of x2 minus x1 square plus we square root the sum of x2 minus x1 square plus y2 minus y1 square. If the distance is bigger than the tolerance, then we will continue the loop, like replace the next point, become current point, and find a new point. When we call the find min function, we pass the function we want, which is sum of square error, and also the number of variable we have, x and y. The reason we pass the sum of square error is because sum of square error calculate all the distance, or we can say the error, square them, add all up, and find the line that makes the line and find the equation that makes the line fit the data as good as it can. We can see, for example, our data set 1. This is the table I make. So when we have x and y and we got a equation called predict y, we pass in the x and y and they will return pass in the x and also the random point. It will give us the result like this. The error is the differences between predict y minus predict minus y, and then we square the error, we will get 4. Sum of square error is the sum of all the square error. So right now let's run the code and see what we get. So for the data set 1, our intercept is 1.0065 and the slope is 1.9979. So this is the equation for the data set is y equal, you can say 2x plus 1. How about when we pass in the data set for, and then we will see how it goes. Okay, if we use data set for when we go through every step, the point will be like negative, positive, negative, positive. There's a way to solve this is we set the step size as a list and then run every step size and find the minimum amount of all the step size. If we run this again, it will go from yeah, if we run this again, it won't like the case before from positive negative positive negative. It will calculate until it find the minimum point and got the intercept and slope. So this is how I implement gradient descent for simple linear regression. Thanks for listening.